What if I told you that everything you thought you knew about reality was just the tip of the cosmic iceberg? Our universe might be just one of countless others, each unique in its own way. Welcome to the multiverse, a concept so bizarre it sounds like science fiction. We're diving into where science fiction meets cutting-edge physics. Imagine every possible outcome of every decision playing out in a parallel universe. The multiverse theory, rooted in quantum mechanics, suggests it might be true. To understand how we even got to this point, to a place where we're seriously considering the existence of multiple universes, we need to take a trip down the rabbit hole of quantum mechanics. Quantum mechanics, you see, is the physics of the very, very small, the realm of atoms and particles that make up everything around us. And in this bizarre subatomic world, the rules of reality as we know them kind of go out the window. Here things aren't so clear-cut. Imagine a world where a coin toss doesn't have a definite outcome, heads or tails, until you look at it. It's in this hazy, uncertain realm that the seeds of the multiverse were sown. You see, in the quantum world, particles don't just exist in one state, they can exist in multiple states at the same time. Hugh Everett III wasn't your typical physics student. While other grad students were content with the standard interpretations of quantum mechanics, Everett dared to think differently, bigger, bolder. His radical idea? Every time a quantum measurement is made, every time one of those indecisive particles is forced to choose a state, the universe doesn't just go down one path, it splits. Boom, just like that, a new universe is born, identical to the previous one right up until the moment of that quantum decision. And in each of these newborn universes, a different outcome unfolds. It's like a cosmic choose-your-own-adventure novel, with every possible ending playing out somewhere in the vast tapestry of the multiverse. At first, Everett's ideas were met with, shall we say, less than enthusiastic applause. The concept of parallel universes, once relegated to the dusty shelves of science fiction novels, was slowly but surely gaining traction in the world of legitimate scientific inquiry. This wasn't just some fringe theory being bandied about by a handful of eccentric physicists anymore. This was getting serious. Think about it. If the many worlds interpretation is correct, then every single quantum event that has ever occurred has spawned a new universe. Every time an electron chooses a particular energy level, every time a radioactive atom decides to decay, bam! A new branch of reality springs into existence. The implications of this are staggering, mind-boggling even. It means that there could be an unfathomable number of universes out there, each with its own unique history and set of physical laws. Alright, let's dive into the deep end of the quantum pool with a thought experiment that's as famous as it is mind-bending. I'm talking about none other than Schrödinger's cat, the feline that's been both alive and dead since 1935. Don't worry, no actual cats were harmed in the making of this theory. This is quantum physics, not some twisted reality show. Erwin Schrödinger, one of the heavyweights of quantum mechanics, came up with this thought experiment to illustrate the sheer absurdity of applying quantum principles to the everyday world. Picture this, a cat chilling in a box, but it's not your average cardboard box. This one's rigged with a radioactive atom, a Geiger counter, and a flask of poison. Now you might be thinking, hold on, that's just crazy talk. The cat is either alive or dead, it can't be both. And in the everyday world, you'd be absolutely right, but in the quantum world, the rules are different. Superposition, my friends, is where things start to get really weird, really fast. It's like the universe's way of saying, why choose when you can have it all? In the quantum realm, particles exist in a hazy cloud of possibilities, a kind of cosmic maybe this maybe that state. They don't have definite properties until they're measured, and the very act of measurement forces them to choose a state. Think of it like spinning a coin. Until it lands, it's both heads and tails at the same time. Here's where the many worlds interpretation comes in to shake things up even further. Remember Hugh Everett and his wild idea that every quantum measurement splits the universe? Well, according to the MWI, when we open that box containing Schrödinger's cat, we're not just collapsing its wave function into one state or the other, we're splitting the entire universe in two. In one universe, the cat is alive and well, probably wondering what all the fuss is about. In the other universe, well, let's just say it's not a good day to be a cat. And here's the kicker: both universes are equally real, existing side by side in the vast multiverse. Now, I know what you're thinking. Wait a minute, if the universe is splitting every time a quantum measurement is made, wouldn't there be an infinite number of universes by now? Now, you might be wondering why we don't see these other universes. Why aren't we constantly bumping into our alternate selves? This is where the concept of decoherence comes in. It's kind of like the cosmic bouncer at the Multiverse Club, making sure things don't get too out of hand. Decoherence is the process by which quantum systems lose their coherence, their ability to exist in multiple states simultaneously, and transition to a more classical definite state. It's like the universe's way of saying, alright, enough with the superposition shenanigans. Time to pick a lane and stick with it. In a nutshell, decoherence happens because quantum systems are incredibly sensitive to their environment. Now, before you go out and buy a lottery ticket based on your chances of winning in a parallel universe, it's important to remember that the many worlds interpretation is still just that, an interpretation. It's a way of making sense of the strange and wonderful world of quantum mechanics, but it's not without its critics and challenges. Some physicists argue that it's just too extravagant, too outlandish to be true. They point to the lack of experimental evidence and the philosophical implications of an infinite number of universes. Others embrace the sheer audacity of the MWI, seeing it as the most elegant and consistent explanation for the mysteries of the quantum realm. So, are we living in a multiverse? The jury is still out and the debate rages on. But one thing is certain: the many worlds interpretation, with its mind-bending implications, has captured the imagination of scientists and the public alike, forcing us to confront the very nature of reality itself. Alright, so we've been through the theoretical ringer, diving headfirst into the mind-bending world of quantum superposition wave function collapse and the audacious many worlds interpretation. But you might be wondering, how does any of this play out in the real world? Does the multiverse have any street cred beyond these wild thought experiments? Well, hold on to your hats, because we're about to enter the realm of quantum computers, where the lines between science fiction and reality get seriously blurry. You see, these aren't your grandma's computers, chugging along with ones and zeros. Quantum computers are like the cool kids on the block, harnessing the bizarre laws of quantum mechanics to perform calculations that would make even the most powerful supercomputers cry in a corner. And guess what? Some experts believe that the way these quantum marvels operate could be a sneak peek into the multiverse itself. Here's the deal: quantum computers rely on qubits, which are like the beefed-up cousins of classical bits. While a classical bit can only be a 0 or a 1, a qubit can be in a superposition of both states simultaneously. Now here's where things start to get really interesting. Some physicists believe that when a quantum computer performs a calculation, it's not just exploring all possible solutions simultaneously. It's actually tapping into parallel universes, harnessing the computational power of countless versions of itself spread across the multiverse. It's like each qubit is a portal to a different reality, and the quantum computer is like a cosmic tourist, hopping between universes to find the answer it needs. It's a mind-boggling concept, but it's one that some very smart people take very seriously. Think about it. If the many worlds interpretation is correct, then every possible outcome of every quantum calculation already exists somewhere in the multiverse. A quantum computer, with its ability to tap into superposition, could theoretically access those parallel realities and retrieve the information it needs. The implications of the multiverse theory extend far beyond the realm of quantum computers and thought experiments. It has profound implications for our understanding of the cosmos itself, shaking the very foundations of cosmology and our place in the grand scheme of things. For starters, if the multiverse is real, it means that our universe, vast and awe-inspiring as it is, might be just one of countless others, each with its own unique set of physical laws, constants, and perhaps even dimensions. Imagine a universe where gravity is a weakling, and you could dunk a basketball from a mile away, or a universe where time flows backward and everyone walks around with a serious case of déjà vu. And here's where it gets really mind-blowing. Some physicists believe that the multiverse could even explain the existence of our universe and the finely tuned conditions that allow life to flourish. You see, the universe we observe seems to be remarkably well suited for life. The fundamental constants that govern the universe, like the speed of light or the strength of gravity, seem to be perfectly calibrated to allow stars to form, planets to coalesce, and life to emerge. This has led some physicists to propose the Anthropic principle, which suggests that the universe is fine-tuned for life because we're here to observe it. Now, the multiverse theory isn't without its critics. Some physicists argue that it's too speculative, too far removed from experimental verification. They point to the lack of direct evidence for other universes and the philosophical challenges of grappling with the concept of infinity. But proponents of the multiverse argue that it's the most elegant and consistent explanation for a wide range of observations, from the weirdness of quantum mechanics to the fine-tuning of the cosmos. They point to the fact that the multiverse is a natural consequence of many of our best scientific theories, like inflation and string theory. The debate rages on, fueled by passionate arguments, mind-bending mathematics, and the insatiable human desire to understand our place in the cosmos. But one thing is clear. The multiverse theory, whether it turns out to be true or not, has already had a profound impact on our understanding of reality. It has forced us to confront the limitations of our perception, the possibility that our universe is just one of many, and the awe-inspiring grandeur of a cosmos far stranger and more wondrous than we ever imagined. So, buckle up, because the journey into the multiverse has just begun. Okay, so we've established that the multiverse is a pretty wild idea, like seriously wild. We're talking about infinite versions of ourselves out there, possibly rocking out to a cosmic karaoke night in a universe where disco never died. It's enough to make you want to grab a telescope and start searching the skies for your cosmic twin. But hold your cosmic horses for a second, because there's a bit of a buzzkill in the world of quantum mechanics, and it goes by the name of decoherence. Yeah, it sounds like a bad sci-fi movie title, but trust me, it's a real thing. And it might just throw a wrench into our multiverse dreams. Remember how we talked about quantum superposition, where particles exist in this hazy state of maybe this, maybe that, until someone decides to look at them? Well, decoherence is basically the universe's way of saying, all right, enough of that nonsense, it's time to pick a lane and stick with it. It's like that friend who always takes forever to decide what they want to eat, driving everyone else at the table crazy. Decoherence is like the waiter showing up and saying, okay, everyone's order is in. Time to make a choice. In a nutshell, decoherence happens because quantum systems are like the gossipy neighbors of the universe. They just can't keep a secret. The moment a quantum system interacts with its environment, even in the slightest way, it spills the beans, revealing its true state. Think of it like this. Imagine a single wave rippling across a pond. That wave is our quantum system in its pure, undisturbed state. But now, imagine someone throws a handful of pebbles into the pond. The waves from those pebbles interfere with our original wave, creating a messy, chaotic pattern. That, my friends, is decoherence in action. In the quantum world, those pebbles are everywhere. Stray photons, tiny fluctuations in the electromagnetic field, even the warmth of your hand. All of these can cause a quantum system to decohere, forcing it to choose a single state and collapse that beautiful superposition. And here's the kicker. Decoherence happens incredibly fast, much faster than you can say Schrödinger's cat. So, in our everyday macroscopic world, we rarely get to see quantum weirdness in action. By the time we even have a chance to observe it, decoherence has already done its thing, sweeping the quantum strangeness under the rug. Now you might be thinking, hold on a minute, if decoherence is so good at hiding the multiverse, how do we even know it exists in the first place? Where's the proof in this cosmic pudding? And that, my friends, is the million-dollar question, or perhaps the multiversal dollar question, that has physicists scratching their heads and pulling their hair out. The truth is, proving the multiverse is a bit like trying to nail jelly to a wall. It's slippery, elusive, and always seems to find a way to wriggle out of our grasp. We can't just hop in a spaceship and go on a multiverse road trip, though wouldn't that be amazing? The realms of the multiverse, if they exist at all, are separated from our own by the very fabric of space-time itself. They're not something we can easily access, at least not with our current technology and understanding. So, how do we even begin to search for evidence of something so elusive, so mind-bogglingly vast? Well, physicists are a clever bunch, and they've come up with some ingenious ideas. Some are looking for subtle anomalies in the cosmic microwave background radiation, the faint afterglow of the Big Bang, hoping to find telltale signs of collisions with other universes. Section 4. The Future of Physics, a Multiverse of Possibilities. Others are building ever more powerful particle accelerators, smashing atoms together at near-light speeds, hoping to create tiny black holes that might offer a glimpse into other dimensions. And then there are those who are placing their bets on the power of quantum computers, believing that these futuristic machines might one day hold the key to unlocking the secrets of the multiverse. The search for multiverse proof is a long and winding road with no guarantee of reaching the destination. But one thing is certain, the journey itself is already pushing the boundaries of physics, challenging our assumptions about the nature of reality and inspiring us to imagine worlds beyond our wildest dreams. So, while we may not have all the answers yet, the very act of asking these questions, of exploring the mind-bending implications of the multiverse theory, is pushing the frontiers of human knowledge and igniting our collective imagination. And who knows, perhaps one day, we'll have our definitive answer, a cosmic postcard from our alternate selves, proving once and for all that we're not alone in this vast and wondrous multiverse. But until then, the mystery remains, and the search continues, reminding us that the universe, like the human imagination, is a place of endless possibilities. Section 1. Echoes of Other Realms. So, we've explored the mind-bending concepts of quantum superposition, decoherence, and the audacious many-worlds interpretation. We've even dipped our toes into the realm of quantum computers, those futuristic machines that might just hold the key to unlocking the secrets of the multiverse. But where do we go from here? How do we go from these tantalizing theories to concrete evidence? How do we find proof that our universe is just one of many, floating in a cosmic sea of possibilities? Well, my friends, the hunt for multiverse evidence is one of the most exciting and challenging quests in modern physics. It's like trying to find a needle in a haystack, except the haystack is the entire observable universe, and the needle is a whisper, a faint echo, from a realm beyond our own. But fear not, intrepid explorers of the cosmos, for physicists are a resourceful bunch. They've come up with some ingenious ways to search for clues, to peek behind the cosmic curtain, and catch a glimpse of the multiverse in action. One of the most promising avenues of exploration lies in the study of the cosmic microwave background radiation, or CMB for short. Now I know what you're thinking, cosmic microwave background radiation? Sounds like something you'd find in the back of your fridge. The Cosmic Microwave Background, a multiversal photo album? The CMB is far from mundane. It's a baby picture of the cosmos, taken just after the Big Bang, a faint afterglow of light and energy traveling for billions of years. Some physicists believe our universe might have bumped into others. These collisions might have left telltale bruises on the CMB. Physicists search for unusual patterns, circular temperature variations. Finding these would be evidence of a grander multiverse. Now, the idea of universes colliding might sound like something out of a science fiction movie, but it's a natural consequence of some of our best cosmological models. Imagine a pot of boiling water with bubbles forming and popping on the surface. Our universe might bump into other universes, creating ripples in space-time, confirming our universe is just one chapter in a much grander story. The search for the multiverse is about expanding the horizons of human knowledge. What is the nature of reality? Are there other universes out there, and if so, what are they like? Are the laws of physics the same, or could they be different? These questions fuel curiosity and drive research. The journey into the multiverse has just begun. We're entering a new era of scientific exploration. Who knows what wonders await us as we venture further into the great unknown? Okay, so we've journeyed through the strange and wonderful world of the multiverse, from the mind-bending concepts of quantum mechanics to the tantalizing hints hidden in the cosmic microwave background radiation. But here's the thing about the multiverse. It's still a topic of intense debate even among the brainiest folks in physics. That's kind of what it's like when physicists start talking about the multiverse. You have the multiverse enthusiasts who see the many worlds interpretation as the most elegant explanation for the universe we observe. The idea of a universe fine-tuned for our existence leads us to the Anthropic principle. This principle has serious philosophical weight. It says the universe is the way it is because if it weren't, we wouldn't be here to talk about it. The fundamental constants have to be within a very narrow range for life to emerge. Tweaking these constants slightly would result in a very different universe. The multiverse offers a possible explanation. Some universes, by chance, have conditions just right for life. It's like winning the cosmic lottery and the prize is existence itself. So where does this leave us? Are we any closer to proving or disproving the multiverse? The honest answer is we're not sure yet. The multiverse remains a tantalizing, mind-boggling concept, a cosmic enigma that continues to challenge our understanding of the universe. But even if we never find definitive proof of other universes, the very idea of the multiverse has already had a profound impact on our cosmic perspective. It has forced us to confront the limitations of our perception, to acknowledge that our universe, vast and awe-inspiring as it is, might be just one small part of a much grander, more complex reality. The multiverse reminds us that the universe is a place of endless possibilities, a realm of mystery and wonder that continues to surprise us with its beauty, its complexity, and its sheer audacity. It inspires us to keep asking the big questions, to keep exploring the unknown, and to never stop marveling at the fact that we live in a universe that allows us to ponder such mind-bending concepts in the first place. The journey into the multiverse is a journey into the unknown, a quest for knowledge that may never truly end. But it's a journey worth taking, for it reminds us of the power of human curiosity, the boundless potential of the human imagination, and the sheer awe-inspiring grandeur of the cosmos we inhabit. So there you have it, folks, a crash course through the mind-bending world of the multiverse. We've journeyed through the bizarre realm of quantum mechanics, where cats can be both alive and dead, and particles throw wild parties called superposition. We've explored the audacious many-worlds interpretation where every quantum measurement splits the universe, creating a cosmic tapestry of infinite possibilities. We've even dipped our toes into the realm of quantum computers, those futuristic marvels that might just be tapping into the computational power of parallel universes. And we've pondered the cosmic implications of it all, from the possibility of bubble universes colliding in the vast expanse of space-time to the Anthropic principle, suggesting that our very existence might be a cosmic lottery win. It's a wild, wacky, and downright awe-inspiring ride, this exploration of the multiverse. It's a journey that takes us to the very edge of human knowledge, to the boundary between science fiction and reality, where the known universe gives way to a realm of endless possibility. And while the multiverse remains a topic of intense debate, even among the brainiest minds in physics, one thing is certain. The very idea of it has already had a profound impact on our understanding of the cosmos and our place within it. The multiverse challenges us to confront the limitations of our perception, to acknowledge that our universe, vast and awe-inspiring as it is, might be just one small part of a much grander, more complex reality. It forces us to expand our definition of what's possible, to embrace the unknown, and to marvel at the sheer audacity of the cosmos we inhabit. So, are we living in a multiverse? The jury is still out, and the search for definitive proof continues. But even if we never find that elusive smoking gun, the very act of asking the question, of exploring the mind-bending implications of multiple universes, has already enriched our understanding of the universe and our place within it. The multiverse, whether it exists or not, reminds us that the universe is a place of endless wonder, a realm where the impossible might just be possible, and where the only limits to our understanding are the limits of our imagination. So, keep looking up at the stars, keep asking the big questions, and never stop exploring the mysteries of the cosmos. For in the grand tapestry of the universe, even the most mind-boggling possibilities might just turn out to be true.